All right, out in front here, you can see my Huff and Puff test bed. High-speed Huff and Puff for 80 meters and 40. It locks at both 80 and 40. I'm going to put a switch in there so the locking points get closer together on 70 meters. Go up and find the Huff and Puff simulator, and you're going to have to run it on older version of Windows. Okay, I'll tell you that right now. It won't work under Windows 10. What you do is you enter in, there's an oscillator here, 60 megahertz, megahertz, I said it correctly instead of megacycles. 60 megacycles, you put in your input frequency that you want to work with. You have a shift register, you put in the number 8, and it'll tell you your locking points for around, like, say, 3.5 megahertz, which would be 80 meters. That's what I was shooting for. Now, if you don't change anything with the input divider, which I tell you to use a 40-40, was this? It would be 74 HC 40-40, not the 40-60. It gives you more outputs in a row, okay, for working with 60, 80 and 40 meters. I said 60. That guy put 60 in my head. He did another email again. So anyway, go look at that Huff and Puff simulator. Hopefully you can get it working. Now, I want to tell you how this journey started. Okay, I had built those 2 ammo can radios from scratch. Radios from scratch. I didn't build the IF cans, but I wound everything else, all the other coils. Anyway, I built 2 ammo can radios. One of them I've already scrapped out, and I wanted to digitalize the next model. Okay, so I went on eBay, and I saw this thing. Okay, so I ordered 2 of them, and I got it home. All right, it came here, and I'm like, well, how do you work this thing? Well, here's the trick. They don't show you what you're actually going to need. Now here, I'll show you real quick. You're going to need the unit. You're going to need some wire. You got to have this keypad, and you also have to have one of these switches. When you press it down, it does one function. You turn it. This is to program this thing, okay? And then once you're in the frequency range you want, you can move up or down using this knob, or you can key in the frequency with this. So now, suddenly, this cute little thing turns out to be this nightmare. No, so then now that you got all these parts, you can power it up and find out how noisy it is. You can find out how much current it wants. So I'm thinking to myself, that's not what I wanted. Okay, so I start looking again, and now I told you Franklin oscillator is one of my favorite oscillators. So I built a Franklin oscillator in an Altoids can, so it would be shielded. I put it on top of this fixture here I made. This is a variable voltage knob which works the varactor in here, and a cute little LCD frequency counter. What happened? I turned it on. Okay, here's the on-off. You can actually shut the frequency counter off and just leave the oscillator on. One way, the light is on the frequency counter. In the middle, the light's off, and all the way to one side, the frequency counter's off. This is exactly what I wanted, but as soon as I turned it on, the Franklin oscillator started running away. And one of the reasons was I used a 360 picofarad cap to run the Franklin. And the varactor diodes, they tell you they're better than a regular variable capacitor that uses plates. It's not necessarily true. It's not true. You get any kind of diode is basically a temperature sensor. So I said to myself, all right, there has to be something else. So I went and built a Huff and Puff. I went through all of the things with that. And then I found out that the 100th digit on this one bobbles. And that annoyed me. So I went through the game of playing with one of these. Okay. This draws more current, but I can shut it off. All right. So with this, I can have a wide range from 80 meters to 40 meters. And I can shut this display off. Now, if we go to this thing, you can't shut the display off. You can't save the batteries. Okay? This is, I guess, was designed to go in a unit that plugs into the wall. That's not what I wanted. Remember, it's an ammo can radio. So I won't say it was a rabbit hole. Okay? The Huff and Puff sort of was. And the reason is, I told you once before, this one guy keeps emailing me all the time. I wanted it for 80 meters. Now, in the circuits that everybody did for the high-speed Huff and Puff, they use an LED. Well, an LED as a variactor does not have enough capacitance to control an oscillator that's at 80 meters. Now, if you let the 80 meter oscillator warm up for an hour, it'll control it. But as soon as the oscillator gets cold and you turn it on, it has no ability to control the oscillator. That's what I learned, okay? So what I use is I use a 40 picofarad variactor. It's right here. And that can lock the oscillator where I want it from the moment I turn it on. Okay? That's what I learned. And I learned that through some other guy who started using, he started to make a multi-band Huff and Puff, high-speed Huff and Puff unit. Okay? And I've been in contact with him. And he showed me the way. Now, the difference between what I'm trying to do is I build my oscillator so it runs 455 above the incoming frequency. A lot of people use 10.5 or 10.5. Well, the FM frequency for IFs, the old IF cans, they use those. Well, that brings the problem back. Okay, when you start going higher in frequency, any little bit of capacitance change due to temperature in your circuit causes you a problem. So by keeping your oscillator lower, you'll have less problems. Now, I think the guy's name was Harris, and he's got a whole thing about how to make an oscillator more stable, what type of capacitors to buy, the whole thing. But he's also shooting for a higher frequency band than 80 meters. Okay. Now, why do I keep saying 80 meters? I know it's like a broken record. Well, at night, when you got free time, if you're older, that's the band that works at night. Okay? Yeah, some of the other bands, sometimes they work pretty good, but that's most likely you're going to find something every night down in the 80 meter band. So I have other radios. So when I build a radio, I build it for my favorite band. I'm not going to build it like say, oh, I'm going to get it so it works on every single band. Well, I have those radios. Okay? And the higher in frequency you go, the more problems you get. And that's why a lot of companies went to these things. Well, these things are noisemakers. And if some guy, oh yeah, you just put it in a can and shield it. It's a noisemaker. Also, if you look at the sine wave that comes out of this thing, it's horrid looking. It's not, it looks like a staircase sine wave. If you know what a staircase sine wave made up a bunch of steps. And I don't like it. I don't want it. So the Franklin oscillator was my favorite until I saw how much it drifts. Now, when you're just receiving AM shortwave stations or AM hams, the frequency drift of the oscillator, when you're on in 80 meters with a 455 IF, you won't really notice it. You might have to touch it up once in a while until the unit's warmed up. Okay? But you put a frequency counter on your favorite oscillator and you think it's doing really good, you know, because I have a Colpitts over here hanging out. So here's a Colpitts, and this thing is very stable. Just a few minutes it warms right up. It's got polystyrene capacitors. The problem is this only does 80 meters. It doesn't do, I can't get, it won't go higher in frequency. It shuts down. Okay, and I used a yellow toroid coil on it, and the yellow toroid coil doesn't expand and contract as much as a regular toroid coil. Okay, those toroid blanks, they're rated differently. All right, some are just meant to be like a bypass or a filter of some sort. It's not meant to be in an oscillator circuit. When you put a toroid in an oscillator circuit for the main inductor, you really want to use a yellow color, and it has less drift. Okay, so you don't make yourself crazy to start with. Now, I just wanted to show you all I've gone through and why I've gone through what I've done. You know, these are cute. And I had it set up that, you know, I could vary the frequency from 3 megacycles all the way up to 10. I could put the display on and off. Yeah, I had everything. This had everything going, and low current draw. Okay, and then as soon as I turned it on for the first time with the display, I'm like, what the hell is that doing? And then I went and compared it to this Franklin over here. That's got a regular capacitor on it, and it doesn't. It's the same circuit. It doesn't drift, and this is also 360 picofarads. It drifts, but not as much as that thing does. So I went reading, and there's people running around telling you a varactor diode drifts less than a regular tuning capacitor, and then other people tell you no, you got to compensate. So I just said, let me go back to where I was at, and I built this fixture with a tuning cap, and it's got a variable, a reduction dial on it built into it, and a Franklin oscillator. And yeah, when you first turn it on, it does drift, but with the Huff and Puff high speed, it locks right away. And that's because I got 440 picofarads worth of oomph to keep that oscillator on frequency. Okay? And if you use an LED, it'll work good up around 5 megacycles and higher. It'll do something. Also, if you use an LED and you have a circuit that's been on a while, it might lock that. But then you shut it off and you go away, you go to bed, next morning you get up, it don't lock. And you're like, what happened? That's because as an oscillator's on for a while, the plates and the capacitors warm up. I know it seems impossible. You know, you're using a FET transistor, you're talking maybe microamps or 1 milliamp, but the plates do warm up. And then the temperature in the room. So your circuit locks perfectly, you go to bed, next day you turn on, you can't get it to lock. But then all of a sudden you start changing some values and it locks. And oh, I had to change the values. That's not what happened. You had the oscillator on long enough, now it's easier to control. And your circuit's working. And then you think you got the values, and then you walk away from the circuit, you shut it off, you come back later, it doesn't lock again. And that's what I'm telling you. That's all I've really gleaned from this project is you got to have enough capacitance to be able to override the oscillator to do what the Huff and Puff tells it to do. All right? If you use an LED diode and you're in lower frequencies, it's not going to have enough oomph. And that's what I'm warning you about. That's the thing that drove me nuts. Several times I thought I had the Huff and Puff working perfectly, and that's what the problem was. Once I went back to 40 picofarads, and then I told you what this capacitor is, the other one, the coupling cap. It might be 33 or something. Anyway, it works great. And I have that guy, he's still emailing me going on about 60 meters. And 80 meters, I'll say it again, 80 meters, maybe 40, but 80 meters. I listen to 80 meters before I go to bed, not 60. And I looked at Wikipedia, and those frequencies you keep talking about are not popular in the United States. Once again, I am in the United States. Everything I build is based on what we use here. And you say, well, there's people in the United States that use 60 meters. Yes, I'll believe that. There's also people around here that use CB radio. But that's not what I listen to late at night. And I was shooting right from the start for 80 meters. Okay? And the one guy's stuff didn't help me at all. Okay? The other guy, the multi-band, I started seeing what I had to change. And it's the divide by chip. When the frequency comes into the Huff and Puff board, in my case, I'm dividing it by 10. Okay? And that's the number you put in the Huff and Puff simulator circuit, simulator program. And that program will not run on Windows 10. So I have an old laptop, an Acer laptop, and I put it in there, and that's where I work it. And I'm working on now a new Huff and Puff that I control a switch, and I'll be able to get closer lock points on 70 meters. 40 meters. All right? I really don't need that, but it's to keep me busy. That's what this whole project was. You know, it started with this. Oh, gee, that would look good in the ammo can, you know? Never thinking, what the hell are all these buttons? You know, they're all programmable. This thing is a nightmare. This belongs in a Chinese radio, okay? And then You buy it, and then all of a sudden, if you're lucky, the vendor has the schematic for the thing. I guarantee you, there are thousands of these sitting right now in a box, in a cellar, in a puddle of water. Because the person got this, and then they said the same thing I did. What the hell do I do now? What are these connectors called? I had to look all that up, and I did a video on this, and I think I might have deleted it. But anyway, I did all the work. Day after day after day, this deep rabbit hole buying this stupid thing, you know? And then I abandoned this, and I went over to this. And this wasn't as bad, you know? But that was my journey, okay? And I can tell you why and how, okay? Because I've done the work. And I also noticed, too, if you ground the chassis of this Huff and Puff, it goes bananas. And my ground in here, I'm out in Lancaster, cow country, but the amount of noise on the grid, the power grid system here is astronomical. We have a bunch of people that have solar, and their unit is outputting noise onto our power grid. Okay, and in the distance, which isn't on ground, we have a lot of electric fences that are pinging high voltage to keep the cows from running away. And you pick that up sometimes. But just wanted to show you my adventure. You know, I know some of you, you're looking at the other video, I guess you like this because this is a project that makes you think. And a lot of the circuits that are there are from guys in other countries. I'm going to say it again. And they're not looking to do 80 meters or 40 meters. They're looking to do 60 and whatever that other, I don't care. I wanted it to work at 80. That's what I right from the beginning, that's what I was doing. And like I said, 80 meters just before bed, I flip it on, I tune around, you get the AM hams that, you know, 10,000 watts or whatever they're running. And some nights they're not on. And then there's a few code guys on at night. And that's about it, you know. I got a lot of radios, okay? And it's the hobby now for me is building the circuits. I have really no use for the radio anymore. I really don't listen a lot anymore, but I really enjoy the circuitry. Why somebody would go through the painstaking effort of controlling an oscillator. Well, if you got a good oscillator, but it drifts, and you put the Huff and Puff on there, it doesn't drift at all. Now you got that really nice clean output of that oscillator, all right, versus one of these things, you know. And I don't have on the side one of those DDS radios. What the hell is it? Software-defined radios, SDR. What pieces of junk those things are. I think that's it. All right, that's it.